As before, our axis of rotation is not always going to be a coordinate axis. And when it's not, say the axis of rotation is the line x equals c, then we need to consider the radius, and the radius is going to be the absolute value of x minus c. It means we're going to use x minus c if the representative rectangle is to the right of the axis, and c minus x if the representative rectangle is to the left of the axis. This doesn't make a whole lot of sense without visuals. So suppose this is the region that we are going to rotate, and this is the region under a curve f from A to B, bounded by the x-axis. We're going to consider a vertical axis of rotation, so I'm going to consider a vertically oriented representative rectangle. Now, we said that if we are rotating about the y-axis, then r, the radius, is simply x, the distance from the y-axis. We're going to see what happens if we have various axes of rotation. Let's suppose our axis of rotation is some positive number less than a. X is equal to c, right? So the axis of rotation is between the y-axis and the region. Then, of course, the distance between the y-axis and the representative rectangle is x, and the distance between the line x equals c and the y-axis is, of course, c. Therefore, the distance between the representative rectangle and the line x equals c is given by x minus c. Then we have this situation here. Let's keep changing it up. Now we're going to have a vertical axis of rotation at x equals c, where c is negative, so to the left of the y-axis. This distance between the y-axis and our representative rectangle isn't changing, so our radius is still going to be based on x. I'm going to tell you, look, it's x minus c, which maybe doesn't make a whole lot of sense until you think about that c is negative. And so if this is something like x is equal to, say, negative 4, then x minus c is equal to x minus a negative 4, so x plus 4. That should make perfect sense, because if this distance is x and this distance is 4, the whole thing is x plus 4. But we still have this expression, x minus c. This is, I think, the last of all the possibilities for a vertically oriented representative rectangle. Suppose our x equals c, our vertical line, is to the right of the region that we're rotating, and we're rotating it about that line. Then we're looking at this distance here between the y-axis and x equals c is c. The distance between the representative rectangle and the y-axis is x. And so this part, the part that's left, is our radius. I should say up here that was our radius too. Anyway, and our radius is given by c minus x, right? So depending on how the axis of rotation is oriented with respect to the representative rectangle, we're always going to be looking at the radius is x minus c or c minus x. Of course, in the case that the axis of rotation is, say, the y-axis, then you've got c is equal to 0, so radius is x. All right, so we're going to see an example of this. Use the method of cylindrical shells. We're going to find a volume. The region is bounded by y equals the square root of x equals 2y, and we're rotating it about x equals 5. X equals 5 is a vertical line. So we have a vertical axis of rotation, which means my representative rectangle is going to be vertically oriented, which means we're going to be integrating with respect to x. That's all the help I'm going to give you for the moment. Go ahead and do this and come back when you're done. Oh, and when I say do this, I mean complete the problem. This one got a little tedious, didn't it? All right, the height is going to be upper function minus lower function, so square root of x minus x over 2. Remember, we're in terms of x, so I'm solving everything for y. And then the radius is going to be 5 minus x, right? That's the distance between the axis of rotation and the representative rectangle. The limits of integration can be tricky sometimes, but it's always, always, always based on the region. And for this region, x goes from 0 to 4. I know that because I set the expressions equal to each other. And after finally multiplying, simplifying, and using the power rule, we end up with that the volume is 136 pi over 15.